welcome back to Algebra 1. We are starting Lesson 3. We are adding signed numbers as well as looking at absolute value. So two pretty simple, fun concepts. So let's get started. All right, here I have the number -4 and +4. It might be a little hard to see from this marker, so I'm going to go over them again in red. -4 and +4. Those numbers basically are the opposite of one another. Every number, with the exception of 0, has an opposite. 0 is the only one that is neither positive nor negative. But every other number, 4, has an opposite, -4. -4 has an opposite, +4. And we have agreed that when we are writing positive numbers, we don't have to write a sign in front of it. It's automatically assumed that it is positive. Now, if I were to graph these numbers on a number line, +4 is here, -4 is here. They both show a distance from 0. +4 shows a distance of 1, 2, 3, 4 places. -4 shows a distance of 1, 2, 3, 4 places as well. So they both show a distance from 0 of 4 places. So both of them have a numeric value of 4. They show opposite qualities, but they both are 4. The quantity is 4. Whether it's negative or positive, their quality is 4. So we designate this as their absolute value. That's basically their distance from 0. So -4 has a distance from 0 of 4. +4 has a distance of 0 also of 4. Now, because we are showing this as absolute value, we have to have a special way of writing this, because we can't just write -4 as 4. That just means +4. So how am I showing that I mean the absolute value of -4? I have to write it in these vertical lines. They're slightly longer than a number 1. And that shows that I'm talking about absolute value. So the absolute value of 4, well, I know that it is 4 places from 0, so it is 4. The absolute value of +4 is also 4, showing that they both have that same distance from 0. So this gives me a rule that the absolute value of every number, no matter what kind of number it is, every number, its absolute value is a positive number. And the absolute value of 0, well, how far is 0 from 0? 0. That's it. So that's your rule. The absolute value of every number is a positive number, and the absolute value of 0 is 0. So look at these. The absolute value of -5, what would that be? It would be 5. The absolute value of -7.12. Well, that would be +7.12. The absolute value of +7.12 is also 7.12. The absolute value of 3/4 is also 3/4. What if you have something like this? You have an equation, you have a problem in your absolute value. Well, you just solve the problem first, and then you write it as a positive number. So here, 11 minus 2 is 9. So what's the absolute value of 11 minus 2? It's the absolute value of 9, which is 9. Here, notice I have a negative sign right here. I have the negative, or the opposite. When we use the negative sign, we also call that the opposite. We have the opposite of the absolute value of 20 minus 2. Well, first solve inside your absolute value. Treat it just like parentheses here. So 20 minus 2, we know, is 18. So I want the opposite of the absolute value of 18. The absolute value of 18 is 18. So its opposite is -18. Okay, so that's absolute value. Now I'm moving on to adding with signed numbers. If you see this, 3 minus 2, most of you are thinking, well, that's just 3 minus 2. That equals 1. But how do we know that we're saying 3 minus 2 and not 3 and -2? Well, really, it's the same when you think of it in terms of something called algebraic addition. And that is by saying that this sign goes with the 2, so that this is indeed a -2. And every number is being added. So instead of 3 minus 2, you have 3 plus a -2. And it actually gives you the same answer. 3 minus 2, you know, is 1. 3 plus a -2 is also 1. Let me show you on the number line how that works. So if you look up here at my same number line, if I show that I'm going 3 away from 0, so that's my +3. I've gone 3 places, here to the 3. But now I want to go -2. So any positive number comes here to the right. Negatives go to the left. So it's 3 plus a -2. So I have to go 1, 2. So this was your +3, this is your -2. And so where did I stop? Right here at the 1. So it's just subtracting it from that number. So 3 plus a -2, we just go 2 places to the left, okay? Based on the commutative property, commutative, there we go, commutative, something like that. I can't speak, you know that. Anyway, based on the commutative property of addition, that means I can move around my addends, the numbers that I'm adding together. So when I change it from subtraction to algebraic addition, that means that I can add in any order I want to. Let me show you with this example, +3 minus 5. Well, remember that's the same as saying +3 plus a -5. So I can add it just like this, +3 plus -5. And remember your rule, 5, when you're adding numbers with opposite signs, here we go, when you're adding numbers with opposite signs, you subtract and take the sign of the larger. So 5 minus 3 is 2. The larger absolute value is 5, so it's -2. Okay, now I switch them based on the commutative property. I'm going to add 5 first to 3. Well, -5 plus 3, we follow the same rule. Subtract 5 minus 3, take the sign of the larger absolute value, which is 5. 5 minus 3 is 2, larger absolute value, -5. So our answer is -2. Okay, we're going to finish this practice on part 2.